everyone, so today's video we are going to look at immunity, okay? Now the first thing that you need to know is that we have barriers that actually stop pathogens getting inside your body, okay? Now those are physical barriers, so they are physically in the way of pathogens getting in, and chemical barriers, okay? So your physical barriers you can see here, you've got your skin, now that is all over your body. You know that generally if pathogens were to get on your skin, they would find it very tough getting through. The problem is that you have is when you have a cut or a wound that hasn't healed properly, that's the only time pathogens can get in via your skin. You also have hairs and mucus in your nose. So remember, mucus is your snots, it's thick and it's produced by goblet cells that line your airways. So though that mucus is there to trap any pathogens that you might inhale, okay? And then you also have this mucus not just in your nose, but along, like I said, along your airways, in your throat, in your trachea, and they also have these ciliated epithelial cells. So you've met these before. They have the little cilia on top to help sweep that mucus down, so you swallow it, or so you expel it out of your nose. Okay, so those are your physical barriers. Your chemical barriers, you have two. So the reason why I've got an eye there is because in your tear ducts you have lysozymes. Now these are special little enzymes in your tears that can actually destroy pathogens. You also, I missed that one there, have hydrochloric acid in your stomach, so that means if you swallow any pathogens in food, you can break those and destroy them before they get into your bloodstream and anywhere else. Okay, so that is your first line of defense. Now, if you if they unfortunately get inside your body, you have to have a more specific defense, which is your immune system, okay? Now, if you are immune to a pathogen, what that means is that you're able to destroy it without getting any symptoms. So if you're immune to something, you have a very quick and a very effective response, okay? Now, if you've never met a particular pathogen before, you will not be immune to it because your body doesn't know how to deal with it yet, okay? So we're going to look at how do we actually build up our immunity. Now, you will have looked at this in year 9, so hopefully this rings a few bells. So your immune system is basically all of your white blood cells in your body. Now, in an exam, you're not going to get a mark for saying white blood cells. You're going to get a mark for using this term lymphocyte. So you have patrolling around your blood throughout your whole body, you have these white blood cells called B lymphocytes. And when a pathogen gets into your body, so it's breached one of those physical or chemical barriers and it's in there now, it's in your blood, the pathogen will have these little proteins on the surface. And these proteins are antigens. Okay, so think pathogens have antigens. Now, fortunately, you can actually detect those antigens. Your white blood cells, your lymphocytes, can detect that that pathogen is foreign. It is not from your own body. So you are going to make an immune response to it. So when the B lymphocyte detects the antigens on the pathogens, it releases proteins of its own called antibodies. And these antibodies destroy the pathogen. Okay, so that is how you fight these pathogens. Now this could be a bacteria, it could be a virus, it could be a protist, it could be a fungi. Okay, but your immune system, your white blood cells, your lymphocytes, are going to attack them. Now after you've had that infection, you have lymphocytes that stay in your body known as memory lymphocytes. And those basically are there in your body after infection and they remain and they understand, they have already met that pathogen. So that means that if you come into contact with that pathogen again, that could be a few months, that could even be a few years later, that B lymphocyte, because it's a memory lymphocyte, will know exactly how to destroy that pathogen. So as soon as it detects it, it will attack, it'll be very fast, it'll be very rapid. When you have the memory lymphocytes you are said to be immune, okay? So your immune response is how you deal with the pathogen. When you've had the pathogen and you know how to deal with it, you're immune. And you're immune because your body has these memory lymphocytes, okay? Now, a skill that you have to be able to do is look at how the responses differ. So the first time you meet a pathogen, we call that the primary response, okay? And the second time you meet, or any further times you meet that pathogen in your life, we call that the secondary response. So this is a graph that we can look at. So you can see on your y-axis, we've got the concentration of antibodies in the blood. Remember, antibodies are those Y-shaped proteins that your B lymphocytes are going to make to attack the pathogen. And then along the x-axis here, we've got time in days. So you can see if this was the first exposure, so the first time the person come into contact ever with that particular pathogen, you can see the concentration of antibodies in the blood will rise as they are making their immune response, but it's quite slow and they don't get, very many. They get enough to destroy the pathogen, but not loads of antibodies in there. So it is enough to deal with the infection. It'll destroy the pathogen, so levels drop, symptoms go away, and then this bit here is the level of antibody that stays in the blood after infection. Now you can see that's just a long interval of time. Like I said, that could be months, that could be years. If that person gets infected with that same pathogen again, you can see that the second time their production of antibodies is a lot faster, and you also make a lot more of them. So just to look at the secondary response up here, you can see the second time you are exposed to a pathogen, the response is faster and you also get more antibodies in your blood. The reason why is because you already have those memory lymphocytes. So when you first, let's go with, cholera, for example, nasty bacteria pathogen that's found in contaminated water. If you were first exposed to cholera, your response would be slow, you'd get the symptoms, you wouldn't produce very many antibodies, you'd produce enough to destroy it, but it would be quite slow, the person would feel ill. If you met that same cholera bacterium again, your secondary response would ensure that you deal with it before the person feels ill. So that's because of your memory lymphocytes. Okay, so the primary response is this one, secondary response is this one, and you have to be able to compare the two. Okay, now as always, we always like to think, what would an examiner want to see in my answer? And again, just like we've looked at before, immunity has a model answer. Okay, so you can break it down into some nice little steps. So whatever the question is, you can be smart and you can think, right, what keywords should I be including in this answer? So for example, if it was explain how a person develops immunity to salmonella bacterium or something like that, I'm just making that up. But whatever the example is, what you are going to see, first of all, the person is exposed to antigens on the pathogen. So whether that is E. coli, whether that is salmonella, whether it's toxoid, whether it's a virus, the person is exposed to antigens on that pathogen. Your next thing you're going to say, B lymphocytes detect the pathogen and produce antibodies. Next, antibodies bind to antigens on the pathogen and this destroys the pathogen. After that, so that's your primary response, memory lymphocytes will remain in the body so that the next time the person gets infected, that means they are immune to that pathogen. So they are, once they've got those memory lymphocytes, they're immune, they will not feel, they will not get the symptoms again. So that would be your model answer, and hopefully you can see what your keywords that are going to be banking those marks are. Alright? Now you can get immunity naturally. So if you are wandering along, you catch somebody coughs, you get that pathogen and you feel ill. That is your natural immunity. However, some diseases are that lethal, people might not actually survive them. So for example, Ebola virus. The death rate of Ebola virus is very, very high. So what we can do, rather than making people have to catch that to become immune, we can induce immunity through vaccination. So vaccines, or you might see the term immunisation, they are just injections. And what they do is they inject a dead or a weakened pathogen into the body. So not the real one, it'll either be just the antigens itself on the pathogen, so just the little proteins around the edge, or a dead version. So that pathogen is not going to cause any harm in that person. However, you will still trigger an immune response. So your B lymphocytes will still detect that dead or weakened pathogen as foreign, and they'll make antibodies. Now that means the person, even though they haven't come into contact with the real pathogen, they will now be immune, okay? So when you are younger, you get vaccines for measles, mumps, rubella, TB. When I was doing my dissertation at university, I had hepatitis injections, so I was immune to that because I was handling blood. So you can actually have these injections and you will make your memory lymphocytes ready to defend yourself, okay? So you don't actually have to catch the disease. If you get a vaccination, you'll get your immunity just by the vaccine. Now with everything, we have positives and negatives of this. So on the plus side, vaccines can prevent epidemics due to something called herd immunity. Now herd immunity is when you get most of the population vaccinated, and that reduces the spread. So if you have a look here, if this person has the disease, so he's got that red arrow there, and only this person here has been vaccinated. If this person here comes into contact with all these people, he can spread that disease on. However, if you have herd immunity within the population and lots of people have already been vaccinated, if this person here has the disease, then if that person comes into contact with this person, this person, this person, this person, or this person, they will not spread the disease on because they are already immune. They have already had the vaccine. So then if any of these come into contact with this person, there hasn't been disease transmission. So herd immunity, vaccines are really useful for that, and herd immunity is basically when lots of the population are immunised, they've had the vaccine, that means there are fewer people to pass on the disease, okay? It can also, vaccines have the possibility to wipe out diseases. So for example, smallpox has been wiped out completely by the use of vaccines. So we can minimise the number of people getting infected. However, you've probably seen, especially with coronavirus in the news at the moment, vaccines can take quite a long time to develop, and we don't have vaccines for every single pathogen. They also don't sometimes always give immunity for life. So you might have to have booster vaccines. Sometimes people can have bad reactions. Now these are rare, but it can happen. So they can have, for example, fever or seizures. And like I said, there's not currently a vaccine made for every disease. So although they are brilliant, it's not possible to have them. HIV, for example, there's currently not a vaccine for that. And like we said, coronavirus, there's not a vaccine for that either. Okay, so that is immunity.